This whole movement really started in the 1950s from what we can see. There's been a universal need for road tankers that can do return hauls for many decades now. Canada was pretty much the first region to do vehicles that do return loads on top of the deck, and they kicked off around about the 1950s. Why Canada is because of their massive lumber industry, and they found they use these vehicles to run diesel up to their lumber operations and then bring back sawn lumber for the housing market in Canada and also the States on top of the tanks. They've got those vehicles running presently, and they've had them running in various forms since about the 1950s. Conventional tankers historically have been one-directional vehicles that can do a head haul and then they come back empty. The empty backload has really been a big part of the fuel business, where it's very difficult to degas a vehicle and use it for anything else. Fuel vehicles have typically got massive manifolds, meter systems, and they're multi-compartment. So degassing of those vehicles is just not practical. But then finding a compatible return load in bulk liquid form is always a mission. There are massive contracting requirements there where one needs to find that compatible return load after every trip. So the benefit of return hauling here is that the decks are open and one can find any number of return loads to go under the tanks as a return load. The regulations out of Europe in the late 1990s kind of spoiled the party for vehicles that do return hauls. What happened there is the European regulations changed the minimum radii on tanks. One couldn't really run sharp radii any longer, and that affected tankers in Europe and also tankers in South Africa, which adopted the European regulations. With the changes in the regulations in Europe, it really meant some tanker makers actually stopped doing vehicles that could do return loads. And this happened in Finland, where the prime manufacturer actually stopped making these vehicles. But the change in regulation really was the trigger or the impetus for return hauler to switch from product on top of tanks to product under the tanks. So yeah, the trigger was regulations out of Europe which affected South Africa. This allowed return hauler to develop its design, which now has been patented in Scandinavia. And we know we will have some sort of traction in Scandinavia because the use of these vehicles in Scandinavia historically from the 1960s.
When it comes to the manufacturing side of the vehicle, we feel that we try to automate things as much as possible with robots, i.e. robot welding we do. The design is monitored continuously through a quality control plan, which we refer to as the QCP. Our third-party approval on the vehicle is that they're on site continuously. So from witnessing the material heat numbers before we start manufacturing right through to the hydro testing of the vehicle. So the plates are seam welded on a seam machine robotically. X-rays are done according to code. On low pressure vehicles and stuff we do 10% on the circumferential, all the T's and long welds. The design, our welders qualification, we do for the international market again, ASME, local for the States, EN for the European markets, and then they qualified, tested through labs, and that for heat affected zone, tensile strengths, bending modulus on it before we manufacture. And then as we manufacture it, it gets monitored continuously.
An issue which comes up with our customers is the issue of center of gravity. These tanks essentially are demountable tanks, the tanks we use in return hauler. They're secured through container locks, twist locks if you will, and we all know the situation with demountable tanks. They fall under different types of regulations to fixed tanks. But this said, we do measure our vehicles as we would measure a standard tanker with center of gravity requirements. Out of Europe, the guys are looking for a 0.4 of a G load on a road with a gradient of 20%, and basically the vehicle needs to pass that roll stability test, and we're achieving that with return haulers. So yeah, that's a measure which we do as well. So on the roll stability side, we are doing our calculations with our axle manufacturers and using an independent measure of roll stability. The design makes loading of the return load no more challenging than loading a standard flatbed. So ReturnHauler gives you acceptable center of gravities, safe handling and operations in other words, and also allows you to operate tanks that are in code, and also helps your materials handling guys who need to load and offload these vehicles. Food grade and chemical tankers typically can be cleaned out at cleaning stations. Being clean bore, easy to clean, and sometimes it's a function of the industry where they need to be cleaned out. So how does ReturnHauler compare to the vehicles that have been made previously that load on top of the tanks? Well, one of the big changes is the deck height. Deck height now is a standard flatbed deck height, which is 1.5 meters, and all the previous vehicles that have run top loads on top of the tanks have been at 2.2 meters. What does this all mean operationally? Forklift drivers now don't have to load decks which are above their line of vision, so it's safer for them, and the forklifts are more stable because the pallet height has got a lower center of gravity. So the forklift operator is a lot happier, and for load securing, strapping, all that sort of stuff is also done at 1.5 meters, whereas these other vehicles at 2.2 meters, bit of a mission, also a bit of a safety problem. Tarping a vehicle or closing up a vehicle, securing a vehicle at 2.2 meters was a bit of a mission. So this is just a lucky consequence of what we're doing, and we're very happy that operators now can load their decks at 1.5 meters. With the tanks raised and out the way, it makes it a very easy loading operation. We're pretty excited about this vehicle for what it can do environmentally. Customers of transport operations can rest assured that their product is getting to them in the most environmentally friendly way. This is quite a vehicle in that it does cut down the carbon footprint and does contribute to a better world by cutting out CO2 emissions. If you're running flat country, it's fair to say you can halve your diesel bill. The half you save will be a cost allocated to your return load. With this kind of vehicle, you're looking at improving your financial result from 60 to 100%, depending on the type of rates that you can attract on your return load. There are clearly some return loads which are very competitive and are sought after by many trucks, and then obviously the opposite is there are some return loads in remote parts of the world where they battle to attract vehicles. So we all know the rating system. If one has got soft rates, you're going to have perhaps a 60% improvement in your financial results. If the rates are hard, you're going to get a better result and maybe 100% improvement in your financial result on a truck. And this increase in revenue can be achieved with fewer truck tractors in your fleet, fewer drivers. Some of the responses from the marketplace have been, you're giving us limited space under the tanks. In the case of the US tanker, we're looking at a head height of about 1.4, 1.5 meters, which is enough for a density as low as around about 0.8, which covers a lot of commodities. And then the issue is you don't have to max out on payload. You can run a 3/4 load, which is sure better than running back empty. If you've got a 75% revenue as a return load versus a 0% revenue, the 75 starts looking quite good, especially if you're running long distance. In other areas, we're finding densities of product can be in the region of 1, which is a specific gravity, obviously water. We can run that as a return load and get your maximum payload. In our designs so far, we have done food grade vehicles, we've done fuel vehicles, and recently we've been asked to do acid vehicles, which transport acid one way and other product back. In our case, we're doing copper loads back, and we're doing batteries, manufactured batteries back. The acid vehicles are quite interesting in that the barrels are a lot smaller, with a density of 1.8 on sulfuric acid. Quite a small barrel, giving you quite a lot of space underneath the tanks for transport of dry freight. And obviously the food grade vehicles we manufacturing for a density around about 1, and also give you nice space under the tanks. Fuel, on the other hand, if you're going for diesel at 0.84, fairly bulky tanks, but still gives you fair space underneath for fairly dense products, which there are enough construction materials, mining materials, steel manufactured products. These types of vehicles, if we look into the far distant future, perhaps when the world's population has perhaps doubled to 14 billion people, might become a lot more pertinent when our highways are twice as congested, when we're belting out twice as much carbon dioxide, and where basically we've got a quarter of the number of drivers that we need to transport stuff around. So perhaps we're a little bit ahead of the wave, but one's got to start somewhere with being creative with empty return loads. So we're hoping our product makes a small contribution in that direction.